cavity or a set of cavities from the library that you download from the website. Now I'm importing in my library from a library I have in the CVest drive, MDTools standard library. Although I already have this cavity, so my block is a sandwich block, and we'll have an NG6 on top and NG6 mirrored bottom. Although these cavities are already in my library, I import in any case. I don't need to import all. I import only the DO3. And with this logic, really, you can import one by one all the cavities the new cavities that library. In my case, this folder is not existing in my library. I have deleted on purpose. So if you mark this checkbox, create library if not present, MDTools will create the library importing the cavity. So I run import, and the cavity now is available in my MDTools library. Of course, we have the possibility to modify our library and our cavity. So I can go into the folder that I have just created. I'll find my DO3. And for instance, I don't like to type in drill, so I just clean up my footprint. The parent cavity is the P port, is visible here. The other cavity related to the parent cavity are visible by clicking the edit footprint command. So here, for instance, I can import my standard M5, and I can click yes. And same here, I can import my standard M5. I have customized the way I define my in my machine drawing my bolt holes. So by using the import cavity data, it is possible to quickly apply the same rules to different drills in your cavity. What I want to do is not only fix this cavity in order to fit my needs, but I also want to create on the fly a footprint that is mirrored with also the O-ring group. So I'm just done with my changes in the DO3 cavity. And I'm going now to create a new footprint called, let me call it the DO3 O-ring. It's a new footprint, so I will just do a save as. So this footprint will be placed on the opposite face. So we cannot keep the same position as for A and B and P and T port and for the bolt holes. In addition, this footprint will have a pass-through bolt holes. So the P port we keep standard where it is. What we are going to change is the position for all the other drills. So BH1, it's not anymore an M5, it will be a pass-through drill. So I'll import cavity data. I'll import my pass-through bolt holes, M5, and I click save. When we mirror a footprint, we need really to define how we want to mirror. So we can mirror on X or Y. So really pick up how you want. Now I'm going to change on the Y direction. So I say epsilon dim is minus 25.9, and BH2 will be minus 26.65. And of course, I need to import the pass-through bolt holes. Same here, that will be plus, and import M5, and same here. With a bit of practice, you can become fast with managing your library. So what we need to do is really we need just to change the, in this case, the X or Y according to what is your decision. Now, as I said, I took the Y dimensions. As you see, slowly all the drills are moving into different positions. So basically, I'm mirroring. The locating pin is not necessary into this kind of footprint, so I'm going to delete it. What I want to do is I want to fix the outline. I need to change the dimensions, so I will edit outline. The outline is linked to BH1, so I can click edit outline. and I'll be able to change the sign. So in this case, it will be 43 minus 11.47. So if I'm good at math, it will be 31.5. I don't want now to spend the time on this message. This will be dedicated to a hydro webinar. But this it's important to verify the net, and to verify the net, I just go to the net, and as you can see, I can highlight each net in my block, and the net are good. So we have a net connected to the tank and all the other ports. I can export to MDTools my document, and I put it into my design folder. Let's call it a sandwich block. Now let me start my design, and if you have questions, feel free to post them. So I'll start with a new project, a new part. In this project, the block will be not very big, and usually we keep it on a width of less than 50 millimeter. Let me put 48 millimeter. Usually the pattern you keep on industrial manifold with the NG6 valve is 50. Sometimes you put more, but not less than 50. So we want this sandwich module to fit into stackable elements. The height may change. Let me put 60 millimeter. Usually this kind of block may become taller if we have many valves. The length may change. Let me put 120 millimeter. Then this will be the biggest variable in our design. I'm going to import the schematic. So MDTools has the ability to import circuit XML file, and I'm going to import the sandwich block. Now, in my hydro, I have called this footprint DO3 mirror, and it's not available. I created a footprint with a different name. It's called DO3 O-ring. So when importing a schematic is not finding the exact cavity name, MDTools will ask you to match the correct cavity name. So this will be my cavity. In addition, my schematic is finding the DO3 cavity in two folders. This is the other folder I had renamed in my library. I want to use the cavity in the folder I have right imported into my library manager. I click assign, so now I'm using that cavity that I have just imported and modified. On the left side, I see all the cavities components with the item ID that was in the diagram that I need to for my design. Usually in this case, we start with a footprint. So let me place my top NG6 footprint with locating pin. And I also place the bottom footprint. I can insert it, place it here. As you see, I have an offset outline. Let me get back. Probably I forgot to save it. DO3 O-ring, edit footprint data, BH1, edit outline. It was 31.525. Save, and we need to remember to save the BH1. And I save again. Let me do again. Let me insert again the bottom footprint. Insert, place it here. Now it's correct. And I can align directly with reference to the same cavity at 0, 0. So now I have positioned my cavities. We will not need the top bolt holes, so we can just suppress them. So we can suppress not the complete footprint, so all the bolt holes. In this recent version of MDTools, to speed up the performance, we group cavities. So sometimes it is not easy to select the cavities that you need to. So if you struggle with selection directly in the model, another technique is directly select the cavities from the ribbon. So for instance, you can do the same command, suppress, and touch the cavities from the ribbon. If you need to suppress cavities, another way is you directly select the cavity from the ribbon, right-click and suppress. Suppress, and this one also. I'll stretch the bolt holes in order to pass through. With the option update bolt hole, we have the ability to extend completely all the 4 bolt holes. Now, identical color means the net is the same, but we want to start placing the valves. So let me start with the component number 4, and let me place on this base. And with colors, we can see, we can connect this one with the green connection in the center. As you can see, there is a slight intersection with the O-ring, this gray area, which is called dead area. This kind of error, potential failure, are found by using the connection check. If you run connection check, MDTools will list all the potential issues in the block. So there are several unconnected ports, but the issue I'm highlighting now is this, which is cavity 1 port B is the bottom footprint, port B is the green one, is touching the cavity 4 with port the D. It's not a port, it's a dead area. Dead area means a thread or chamfer, any part where we don't want to have oil. We don't want to have oil, but we have a sealing part. Now we need to start placing some construction plugs. In the settings, in MDTools settings, we have the ability to define the construction plugs that we want to define to use in our design. Usually for these small blocks, I try to use expander plugs. So I don't want now to use the short ports. I delete them and click new and select the expander plug. Remember that this selection will not be my next default. In my next block, I will still find my short ports. So if you start a design and change the construction plugs on a design, this selection will be valid only for that design. If you want to change your preferred settings for construction plugs, you need to start a blank part, change and apply the changes. So then it will override the standard defaults that you have in your configuration. Now I'm going to stretch a bit this face in order to get rid of that L intersection. So I'll make it 130. My engraving can be moved, so you can select it and move it on a different position. I need to connect the orange lines, so let me do a construction port, touching the port number 3. Automatically, MDTools will take an MB 019. I go for a 070 and touch the bottom face. By default, it will put the connection in the center. And I want to place another plug touching this construction plug and also the other orange connection. We can continue and place the cavity where we want. Now let me place the other cavity, and I place on the opposite face. And I leave it as is. So we see that the orange should be connecting to the other orange, and that's a bit challenging. So this is very common in this kind of block. We'll need to do some inclined drills. So I decided to incline the yellow. So the easiest way to incline a drill is to use the stretch drill command. You touch the drill and you apply an inclination, maybe 10 degrees. You can change the orientation. The orientation is the alpha. And if you want only simple angle, please use alpha 0, 90, 180, and 2070. So 90 degrees. Let me make slightly more than 10 degrees. I make 13 degrees. In this case, MDTools is warning me because the drill, which was a 7, cannot be anymore 7 because it's exceeding the maximum diameter accepted on the plane. So in this case, I'm not going to continue. I will put a 6 mm diameter. In order to standardize my drills, I wanted to use the 6 mm on all the drills here. So I will use the match property command, selecting the source cavity and all the destination cavities. And I will copy the drill diameter so that now, also in terms of manufacturing, there will be less tool change. Let me verify this drill. It looks larger. Yes, it's 7. And let me replace this plug with an expander 060, 070, so that it can have a 6 mm diameter. With the same logic, now I can incline this other yellow connection with, let me keep the same inclination, 14 degrees. Now it's going to 270 degrees. The reason for doing that is I need to find a place to make the orange connection enter and do the connection with the other line. I'll most likely need to add some material. So let me create on the height. I'm going to add 5 mm. I'll move my cavity slightly on the left, on the right, so that I can see it. And yes, most likely I will be able to do a connection. So in this case, I want to make an offset hole. So I will do an offset hole on this cavity. I'll take a 6 mm diameter. The offset hole will be maybe 3 mm, too much, 2 mm. And click OK. And I can stretch this drill on this direction. So in this case, I can move this cavity slightly to the left in order to make a connection. And I'll move also slightly to the left this other drill so that I have made a connection. This probably, it could make sense to have a larger drill, but let's keep this for a moment. Of course, I am not able to make this drill going straight because there will be an intersection. When you don't notice this kind of intersection, those are always highlighted in the connection check. So connection check will be able to find also wrong connections. So in this case, there is a wrong connection between the plug 3, which is my offset drill, and the port E-net5. In this case, the P port is blue. I want it to be red. If you want to change color to a net, you need to go to the model browser, nets, and you can also change name to a net. So you can double click and change the name to a net. This is something I don't recommend to do when you import a diagram from HydroCAD, because that will somehow break the link with Hydro diagram. But in this case, the schematic is simple, so I don't mind. The other net is the tank, so I call it tank, and I change color to use a light blue. So in order not to have this interference, I will need to copy to use the match properties and apply the same rule alpha and beta. And same here. And this one will be inclined by 90 degrees. Let me undo, there is something wrong here. For some reason, I lost the O-ring. I'll delete and add the O-ring later. So let me incline this drill. I make 14 degrees by 90. And it looks good. Let me stretch the drill. So I have connected the red. Let me extend the yellow. And with the same logic, I need to stretch this drill. But actually, this could be straightened. So let me put it here. And this one here. We'll see it later. Sometimes we see these graphical artifacts, the color will not be visible. We are able to regenerate the color by using the color command. We can verify the distance or the wall thickness. So if you want to measure the distance, you click measure distance and select the drill and the other drill. And so this is 3.3 millimeter. It's not a lot, but for this kind of geometry is really, if the machinist is pay attention, that should not be a threat. If really we want to be safe, we should need to incline also the tank line. I don't want to incline for this project because I want to explain another technique I frequently adopt for the machine drawing. So basically, this blue, light blue connection becomes a pass-through bolt hole. I usually split the drill into two parts because I want both dimensions to be automatically made in the machine drawing, and we will see later in the machine drawing. What is interesting is that if I edit one of these drill and go to edit all parameters, now you will see that what I expect to see in the machine drawing will be $0, which means the depth, which means 36 millimeter. If you want in the drawing to be written through, that you can type it through. So now by modifying manually this, I will expect in the machine drawing to see the both drills. So I do the same on the footprint 1. edit cavity, and then make it through. So we will see in the machining drawing that this drill will both show through. So then it will be a strategy of the machinist, of the vendor, if he wants to split. So for the designer, it's not important. It's important to have the two drills, the connection between the drills. It's not important which drill is made first or which drill is longer or shorter. The connection check will always inform us of missing connections. So in this case, it is called a broken net. So broken net means, in this case, the yellow connection, and we need to connect the yellow. So net 2 and net 3. Let us do that. It will be tricky. This kind of blocks, although they are very similar from schematic perspective, becomes very tricky from a design solution because of the big constraint due to the width of the block. But we are able to find a solution here. So let me create a plug here. And this plug can be moved slightly to the right. And let me copy the plug here. And I want to connect with port 2. And I want to reference also to the other cavity. So I want to keep it at 0. I forgot to select the other cavity for connection. We can stretch it. So the green net looks okay. And we need to fix the yellow net. And again, we will do a construction port number 2. We can make it tangent or slightly to the left. And here probably we will discover that we will need to incline also the light blue connections. And let me copy the same plug here. And I will connect them. And I stretch this drill in order to reach the other yellow connection. Yes, really, my bad. I need to incline also the 2 tank lines. So in this case, really, it's important that we then fix also the machining instructions. An easy way to fix machining instruction is always match properties. This drill with this one, we copy everything and the machining sequence. In order to be able to copy the machining sequence, you must have equivalent cavities. So you will not be able to copy machining sequence between a C10-2 valve and a BSP port. In this case, they are drills, so it is possible to copy the machining instructions. Let me use always stretch and change the inclination. It's 90 degrees. And the same will be here. I had lost the O-ring, so let me add the O-ring. The O-ring can be added by using the O-ring group command. So you touch the cavity and you select. I want a counterbore O-ring 012 size. And same here, O-ring, counterbore, same. O-ring. Looks good. Let me try to run the connection check. Start. There are no issues. So the big benefit of using Hydro is really that we can focus on finding the way to connect our drills. So we don't spend too much time then in verifying which drill has to be connected with other. So although I repeat myself, this block is relatively simple if we look at the schematic. Still, there are a lot of connections needed, strange drills, inclined drills, so the mistake is easy to make. By using this color code nets, it becomes easy to find out a solution and to check it. I want then to verify the wall thickness. For such a block, 5 mm would be too much. I'm sure there will be issues. I'll run a check for 3 mm, and still there are some issues. So there is a 2.9 distance between this cavity and the bolt hole. That's easy to fix. I can shorten this drill. That's not a problem. There is also 2.9 mm distance between the inclined P-port and the green. Then there is a 2.75 mm distance between the locating pin and the bolt hole. That's not a threat. And there is a 3 mm distance between orange and yellow. I got used to MDTools, so I can find I can understand the issue without too much effort. If you struggle in the beginning, another options could be switch on. Let me save my block. Sandwich block. If you struggle with finding the error, you can go to the settings, miscellaneous, and switch on this option, remove color from unselected cavities. These options, for instance, when we run the wall thickness check, will remove all the colors from the cavities. And when you touch an issue, it will highlight the issue. It's not always precise. In this case, it's showing the wrong segment. But by highlighting with color, it can be easy to locate the issue. So here, for instance, we can see a distance between spot face. That will not be an issue. Or here, same. I don't use this technique because for this block, really, it's not time consuming, but for larger block, it may slow down my way of designing the block. So I usually keep the highlighted selected cavities. I don't need the engraving on the top block and on the bottom. I may need an engraving for my, so I manage and I type the part number, for instance, May webinar, and the location would be somewhere here. Engrave. If you want non-cosmetic engraving, just switch to modify all, and you make non-cosmetic. So this will be non-cosmetic. You can define the depth of cut. Let me make 0.5 mm. So my block is ready. I now switch to the assembly. I didn't show you, but my schematic had all the information for the valve. So this valve is a Hydraforce SV821, and I already linked the CAD file for the coil and for the cartridge. And this valve is a Parker pilot operating check, pilot close operating check. And also this one as the 3D model. So the assembly will be really very, very easy. I will just need to create a new assembly. And I can run the automatic assembly. Auto assemble, yes, and I'll take my sandwich block. The coil can be rotated. Let me rotate this way. All the expander have already been placed in the correct position. There is no assembly, automatic assembly for the O-ring. For that, you will need to use inventor or SolidWorks command. But that's my block. Let me save it. Let me call it assembly. If this block had to be assembled on other MDTools block, it is possible to set it as with rules for assembly. So we did some webinar in the past for assembly rules. Let me quickly spend a few words here. So the assembly will need the two axes, which are the corresponding to BH1 and BH2. BH1 and BH2, they are the opposite to the P port. So in my case, to define the assembly rules, I will need assembly constraint, valve pattern. Top face is the one without O-ring. Bottom face is the one with O-ring. The first axis is this one, and the second axis is the other one. BH1 and BH2. Set constraint. Okay, as you can see, 4 entities have been created in the assembly environment. So now this component can be automatically assembled in another assembly by using MDTools commands. I'm not going to demonstrate it now. We don't have much time. I want to switch to the machining drawing. So I'll make a new manifold drawing. It's not a large block, so let me reduce a bit the size. Let me make an A2. So I can create views of my block, and the block is my sandwich block. Let me put the sixth view down, and I click OK. As you can see, all the inclination are displayed with an arrow. We can highlight construction plugs. So in this way, MDTools will create a cross for each construction plug. We can add the dimensions. If you don't like the origin, feel free to change the origin on the view. And you can define each view independently and then project or keep standard projection. Start auto dimension, and this command will create all the dimensions in the block. If you want, you can describe, you can add the component, the footprint port application name, so ABPNT, and this will apply the text next to the drills. If you want to move them, you just need to drag the text. Double click, it will edit the sketch, and it will be able to position. I like the machining drawing with the machining callout, so I'll do that. Machining callout, create. This command will create all the information for the drills according to what was defined in the library. In this case, in the machining callout, in the settings, I was using the depth to tooltip. Let me go to full diameter depth. And let me create again. So now there will be a change in the depth. It will be depth to tooltip. Make sure that MDTools will be able to calculate also the depth to tooltip. Remember always to indicate in the title block if you are showing the depth at tooltip or full bore depth. So what we can do is just move the nodes. And as you can see, for the bolt holes, it's just showing the diameter and depth. The O-ring groove are displayed in this way. That's something I changed recently in my library. If you want to group identical machining callout, that is not possible automatically with MDTools so far. I hope that we will be able to provide some technique to do that. So what you need to do is really you can delete and edit the machining information, adding number 4. Remember that if you do a change in the machining zone, it will update the what you have deleted will show up again. So still some manual work will need to be done. In the machining drawing, I like always to add the symbols, the cavity symbols, to help the manufacturer. So this is how I add all the cavities. This is not part of MDTools. So I have an S8-3, S8-2, expander. There is also the ISO, the C-top 3, which I put maybe on the other side, and also there is an O-ring group. So I'm done. Of course, then you can print the drawing and you are good to go. I turn it over to you, Frank.
All righty, thank you, Carlo. That's all the time we have today. So if you have any follow-up questions, please send us an email at support@bestusa.com with further details, and we'll be following up with you. I'd like to thank Carlo for delivering today's product application demonstration. We would appreciate if you can complete a short survey at the conclusion of today's webinar. Also, tomorrow you will receive an email containing a link to view a replay of today's session. Please feel free to share this link with your colleagues. Included with that link will be a link to view video segments from prior webinars as well. As you can see, we also have the webinar series posted on various social media channels. We invite you to follow these channels so that you can get the latest updates on these upcoming webinars. Our next webinar is scheduled to occur Wednesday, May 18th, a week from today, where an overview of the HydroCAD product will be presented. Thanks again, Carlo, and thanks everyone for attending today's session. Have a pleasant and safe day.